Right now, beneath the Mediterranean's blue waters, a hidden volcano is growing. And after 400 years of silence, it is waking up. Just 4 miles from Santorini, one of the most visited islands on Earth, scientists have discovered something terrifying. A massive magma chamber that has been building for nearly 4 centuries. Enough molten rock to fill 500,000 Olympic swimming pools. And it is still growing, every single year, without stopping. In January 2025, the ground began to shake. Over 30,000 earthquakes in 30 days. The Greek government declared a state of emergency. Schools shut down. 11,000 people fled the island. But here is what has scientists in complete panic. When researchers finally looked beneath the surface, they discovered that Santorini and this hidden volcano are not separate systems. They are connected, breathing together, sharing the same deep reservoir of magma, 20,000 residents, 3.5 million tourists every year, and a volcano that is recharging itself for an eruption that could match the disaster that wiped out an entire civilization. Is Santorini sitting on a time bomb, or has the countdown already begun? When most people picture a volcano, they imagine a mountain spewing lava, fire, and ash visible for miles. But the deadliest volcanoes on Earth are often the ones we cannot see. They hide beneath the ocean surface, building pressure in darkness, far from human eyes. And there are far more of them than the volcanoes on land. Columbo is one of those invisible giants. It sits approximately 4 miles northeast of Santorini, buried 1,600 feet below the Mediterranean surface. No smoke, no visible crater, no warning signs that tourists sipping wine on the caldera cliffs would ever notice. Just blue water hiding a geological nightmare. The location is not random. Columbo lies along the Hellenic volcanic arc, one of the most geologically active regions in the Mediterranean. This is the same zone that produced the catastrophic Thera eruption around 1600 BCE. The same eruption that generated tsunamis across the eastern Mediterranean and practically erased the Minoan civilization from history. And Columbo is not alone. It is part of a volcanic field containing at least 25 submarine cones, all aligned in a chain stretching northeast from Santorini. An underwater mountain range of potential destruction that most people have never heard of. The geological mechanics driving this system are relentless. The African tectonic plate is diving beneath the Aegean plate at a rate of approximately 1 inch per year. As the African plate descends into the Earth's mantle, it melts. That molten rock rises toward the surface, accumulating in chambers beneath the seafloor. The process never stops. The pressure never releases. The magma keeps building. For years, scientists studying this region faced a fundamental problem. They knew magma was accumulating beneath Columbo. Seismic data confirmed volcanic activity, but they could not see how much. Traditional monitoring methods failed to penetrate the seafloor with enough precision. The question haunted researchers across multiple institutions. How much magma is down there? How big has this hidden chamber become? The answer would take revolutionary technology to uncover. And when scientists finally saw what was beneath Columbo, the data exceeded their worst projections. The Mediterranean has a long memory of volcanic catastrophe, and the region surrounding Santorini holds some of the darkest chapters in that history. Around 1600 BCE, the volcano known as Thera erupted with almost unimaginable force. Scientists estimate the explosion released energy equivalent to hundreds of nuclear bombs detonating simultaneously. The eruption column punched into the stratosphere. Tsunamis radiated across the eastern Mediterranean, devastating coastal settlements for hundreds of miles. Ash buried entire cities. The Minoan civilization, one of the most advanced cultures of the ancient world, never recovered. Their palaces crumbled. Their trading networks collapsed. Within generations, a civilization that had thrived for centuries practically vanished from history. One eruption rewrote the future of an entire region. That was the power contained in this volcanic system. And Columbo sits in the same geological zone, fed by the same tectonic forces, building pressure through the same mechanisms. The last time Columbo erupted was 1650 CE. The historical records from that event are chilling. Pyroclastic flows, superheated currents of gas and rock traveling at hurricane speeds, crossed the sea surface and reached the shores of Santorini. Toxic gases spread across the island. 70 people lost their lives. For that era, with a much smaller population, the death toll represented a devastating blow to the community. Since that eruption, nearly 400 years have passed. Columbo has remained silent. No explosions, no pyroclastic flows, no visible activity disturbing the Mediterranean waters above its crater. But volcanic silence is deceptive. It does not mean safety. It does not mean the system has gone dormant. In many cases, silence means exactly the opposite. It means pressure is accumulating, magma is rising, energy is building in chambers that human eyes cannot reach. Scientists studying Columbo understood this principle. They suspected that beneath the quiet seafloor, something was growing, something potentially massive. But suspicion is not data. They needed to see inside the volcano itself. That breakthrough would not come until 2022. And what researchers discovered changed everything. In October 2022, a study published in the journal Geochemistry, Geophysics, Geosystems delivered findings that sent shockwaves through the volcanology community. A research team led by Kajetan Krapkowicz, a geophysicist at Imperial College London, had finally seen inside Columbo, and what they found exceeded every expectation. The breakthrough came from a cutting-edge technology called full waveform inversion. Traditional seismic monitoring could detect that volcanic activity existed beneath Columbo, but it could not produce detailed images of the magma chamber itself. Full waveform inversion changed that completely. The technique works like a medical ultrasound, but applied to volcanoes. Researchers aboard a vessel fire powerful sound waves toward the ocean floor. Those waves travel through the rock beneath the seafloor. When they pass through solid material, they move fast. But when they encounter molten magma, the speed drops dramatically. By measuring these speed differences across thousands of data points, scientists can construct a detailed three-dimensional image of what lies beneath the surface. It is essentially an X-ray of the Earth's interior. And the image that emerged from beneath Columbo revealed a magma chamber that nobody knew existed. The chamber extends from approximately 1.25 miles to 2.5 miles below sea level. That is 2 to 4 kilometers of vertical depth where molten rock has accumulated over centuries. The width measures roughly 2,000 feet, approximately 600 meters across. The structure is massive by any volcanic standard. But the dimensions alone did not alarm researchers. Magma chambers exist beneath many volcanoes worldwide. What alarmed them was the volume of accumulated magma inside this chamber and the rate at which that volume was growing. The numbers Krapkowicz's team calculated defied initial projections. This was not a modest accumulation building gradually over centuries. This was a system charging itself with extraordinary speed, a volcanic reservoir filling with molten rock year after year, decade after decade, completely hidden from human observation. The data demanded immediate attention, and when scientists quantified exactly how much magma Columbo contained, the implications became terrifying. The total volume of magma accumulated inside Columbo's chamber measures 1.4 cubic kilometers. That is approximately 1/3 of a cubic mile of molten rock. The number sounds abstract until you translate it into something tangible. That volume would fill more than 500,000 Olympic-sized swimming pools, not with water, with molten rock at temperatures exceeding 1,800 degrees Fahrenheit over 1,000 degrees Celsius, hot enough to vaporize anything it contacts instantly. But the volume alone is not what keeps volcanologists awake at night. The truly alarming metric is the rate of growth. According to the 2022 study, Columbo's magma chamber has been expanding at an average rate of 141 million cubic feet per year since the last eruption in 1650. That is 4 million cubic meters annually. Every single year for nearly 4 centuries, without interruption, without release. The pressure simply keeps building. Krapkowicz himself explained the implications. If this growth rate continues, within the next 150 years, Columbo could reach 2 cubic kilometers of accumulated magma. That number carries a specific and terrifying significance. 2 cubic kilometers is exactly the estimated volume expelled during the 1650 eruption. the same eruption that sent pyroclastic flows across the sea surface and killed 70 people on Santorini. In other words, the volcano is recharging itself, preparing for something comparable to what happened 400 years ago. The research team emphasized that this system displays characteristics indicating a highly explosive eruption. They compared its potential style to the Hunga Tonga eruption of 2022. That Pacific explosion generated tsunami waves reaching 66 feet in height. The eruptive column punched into the stratosphere, visible from space. Now consider the geography. Columbo sits just 4 miles from Santorini. The island hosts 20,000 permanent residents. Every year, 3.5 million tourists visit those famous white cliffs and stunning sunsets. A volcano recharging for a catastrophic eruption. Millions of people within immediate range, and a magma chamber that grows by 141 million cubic feet every year without stopping. The clock beneath the Mediterranean keeps ticking. On January 27, 2025, seismic monitoring stations began recording unusual activity approximately 6 miles northeast of Santorini, directly above the Columbo volcanic field. What started as scattered tremors quickly escalated into something unprecedented. Over the following 30 days, more than 30,000 earthquakes shook the region between Santorini and the neighboring island of Amorgos. The University of Athens reported staggering numbers. Over 15,000 quakes recorded in just 15 days. Nothing of this intensity had ever been documented in this region. The largest tremor reached magnitude 5.2 on the moment magnitude scale. Strong enough to crack walls. Strong enough to send objects crashing from shelves. Strong enough to remind every resident on Santorini exactly what lies beneath their feet. The Greek government responded with emergency measures. On February 6, 2025, officials declared a state of emergency covering Santorini. The declaration remained in effect until March 3rd. Schools shut down immediately. Classes suspended indefinitely as authorities assessed structural safety across the island. Officials issued an unusual warning to residents: drain your swimming pools. The reasoning was grimly practical. Water sloshing during repeated earthquakes could destabilize building foundations. The constant tremors made even standing water a potential hazard. Approximately 11,000 people made the decision to leave. Some evacuated to the Greek mainland. Others relocated to nearby islands outside the immediate danger zone. Families packed essential belongings, uncertain when they might return, uncertain what they might return to. Tourism bookings evaporated overnight. Hotels reported mass cancellations. An island economy built on visitors watching sunsets over the caldera suddenly faced the possibility that the caldera itself was awakening. The question on everyone's mind was immediate and terrifying. Was Columbo erupting? Were the 30,000 earthquakes the precursor to something catastrophic? Scientists scrambled to analyze the seismic data flooding in from monitoring stations. They needed answers. The residents of Santorini needed answers. In November 2025, a study published in Nature finally provided an explanation. And what researchers discovered was more alarming than anyone anticipated. The November 2025 study, published in Nature, delivered a revelation that fundamentally changed how scientists understand volcanic risk in this region. The findings were as elegant as they were terrifying. Santorini and Columbo are not separate volcanic systems. They are connected, fed by the same deep magmatic reservoir buried miles beneath the Mediterranean sea floor. For decades, researchers had studied these volcanoes as independent threats, separate risk assessments, separate monitoring protocols, separate evacuation plans. The Nature study demolished that assumption entirely. The research team analyzed more than 25,000 earthquakes from the 2025 swarm using artificial intelligence. The AI processed seismic data at speeds impossible for human analysts, identifying patterns that traditional methods would have missed. What emerged from that analysis was striking. Beginning in mid-2024, the Santorini caldera started inflating gradually. Magma was pushing upward beneath the famous tourist destination. But the source of that magma was not directly beneath Santorini itself. The inflation preceded the intrusion of a magma-filled dike originating from a mid-crustal reservoir beneath Columbo. Sheets of molten rock had sliced through the Earth's crust, at depths exceeding 6 miles, covering an area of approximately 12 miles. The volume of magma involved in this single intrusion event would fill 200,000 Olympic-sized swimming pools. The magma did not reach the surface. This time, physical evidence confirmed the connection between both systems. During the crisis, instruments recorded the seafloor directly above Columbo, sinking by 13 inches. Simultaneously, the surface of Santorini rose by more than 4 inches. The interpretation was unmistakable. Magma was redistributing between the two volcanic systems in real time, pressure releasing from one location while building in another. Scientists described it as if both volcanoes were breathing together, sharing the same underground heartbeat. This discovery transforms every risk calculation for the region. Emergency planners can no longer treat Columbo and Santorini as isolated threats. Activity in one system directly affects the other. Two volcanoes, one shared reservoir, and 3.5 million tourists visiting the danger zone every year. Columbo is not the only hidden danger lurking beneath Mediterranean waters. Approximately 109 miles south of Naples, Italy, another submarine volcano sits in the Aegean Sea. Its name is Marsili, and almost nobody has heard of it. The scale of Marsili defies expectations. This underwater giant stretches approximately 43 miles long and 19 miles wide. That makes it larger than Mount Etna, the most famous volcano in Europe. Marsili rises nearly 10,000 feet from the seafloor. Its peak sits just 1,500 feet below the surface, a massive volcanic structure hiding in plain sight beneath busy shipping lanes. Scientists call it the most underestimated volcano on the European continent. The Italian National Institute of Geophysics and Volcanology has issued stark warnings about its condition. Marsili has fragile walls composed of unstable rocks. A shallow magma chamber feeds the system from below. The combination creates a structure vulnerable to sudden catastrophic failure. Researchers at the University of Bologna ran simulations modeling what happens if Marsili experiences partial flank collapse. The results were alarming. Tsunami waves would reach the Aeolian Islands in approximately 10 minutes. The coasts of Calabria and Sicily would see impact within 20 minutes. In the most extreme scenarios, waves reaching 66 feet could strike populated coastlines. The Mediterranean faces a critical vulnerability that the Pacific does not share. There is no robust tsunami warning system covering these waters. The distances between submarine volcanoes and populated coasts are simply too short. Reaction time is measured in minutes, not hours. By the time warnings reach coastal communities, the waves may already be visible on the horizon. The pattern emerges with disturbing clarity. Hidden submarine volcanoes scattered across the Mediterranean. Densely populated coastlines within immediate striking distance. Inadequate warning infrastructure to provide meaningful evacuation time. Millions of people living, working, and vacationing in zones that volcanic tsunamis could devastate with almost no notice. Columbo threatens Santorini. Marsili threatens southern Italy. The Mediterranean's hidden volcanoes are not isolated threats. They represent a systemic vulnerability that scientists are only beginning to understand. Scientists are not standing idle while these threats build beneath the Mediterranean. The 2025 crisis triggered an unprecedented acceleration in volcanic monitoring efforts across the region. In December 2025, the research vessel Meteor departed on the Santorini expedition, carrying advanced submarine monitoring equipment designed to track volcanic activity in real time. The mission's goal is testing innovative sensor systems that can detect changes in magma movement weeks or months before surface signs appear. Early warning capabilities that could save thousands of lives. The Santorini Observatory has maintained continuous monitoring of Columbo since December 2022. Seismographs track every tremor. Pressure sensors measure changes in the seafloor. Satellite data captures surface deformation across the caldera. The network grows more sophisticated with each passing year. During the 2025 earthquake crisis, researchers installed new seismographs directly inside Columbo's crater. Equipment now sits on the seafloor 1,600 feet below the surface, recording data from the volcano's interior. Information that was impossible to gather just 5 years ago now streams continuously to monitoring stations. The progress is measurable and meaningful. Scientific understanding of this volcanic system has advanced more in the last 3 years than in the previous decades combined. Every new data point refines risk assessment models. Every improved sensor makes early warning more precise. Every research expedition expands the picture of what lies beneath these waters. International cooperation has intensified as well. Greek, Italian, and British research institutions share data across borders. The European scientific community recognizes that Mediterranean volcanic threats do not respect national boundaries. A Columbo eruption would affect shipping lanes, air traffic, and coastlines across multiple countries. Preparedness requires coordination that matches the scale of the threat, but fundamental realities remain unchanged. The magma chamber beneath Columbo continues to grow. 141 million cubic feet of molten rock accumulating every year. The pressure does not pause for scientific conferences or research expeditions. The geological clock keeps its own schedule. The connection between Columbo and Santorini adds complexity that researchers are still working to understand. Two volcanic systems breathing together, sharing magma, potentially triggering each other. The 2025 crisis demonstrated that activity in one system can redistribute pressure to the other within days. Monitoring one volcano is no longer sufficient. Scientists must track both simultaneously and interpret their interactions. The tourists will return to Santorini. They always do. The white buildings clinging to caldera cliffs will fill again with visitors chasing famous sunsets. The wine will flow. The photographs will multiply across social media. The island's economy depends on the world forgetting, at least temporarily, what lurks nearby. But 4 miles away, and 1,600 feet down, the magma keeps rising. The chamber keeps expanding. The system keeps charging itself for an eruption that historical patterns suggest is not a question of if, but when. The Mediterranean holds its breath. The volcanoes do not. Somewhere beneath the blue waters that millions consider paradise, the clock that started ticking in 1,650 continues its patient countdown. And every year it grows 141 million cubic feet closer to zero.